All right, method of sections. Method of sections really is based on all the same assumptions that the method of joints was based on. So what you're going to find, though, is where method of joints, a lot of times we say, hey, find all the members in this truss, give me the magnitude and give me the type of force for all members in this truss. With method of sections, we usually go after specific members. So you might only have 3 members out of a truss, and the method of sections will say find A, B, B, C, and C, D. Okay? It's more streamlined in the approach. Number one, because you're not finding all the members in the truss, but 2, because you create your own free body out of the truss that will help you solve for the particular members that are asked. With the method of sections, you're still going to be dealing with joint forces. A lot of people, as we write or draw, a section, a new section up there, and start to solve using the method of sections, a lot of people think that we're somehow doing something different. We're not. We're still using joint forces. So just like with the method of joints, I said we use the joint forces, but really we're solving for the member forces. That still holds true. A lot of the stuff that I do with the method of joints, I'll still do with the method of sections. One of the things that I do that's just a personal habit is when we are using the method of joints, I always draw joint forces acting away from the joint. We talked about this last week. I might find that that's correct, or I might find that that's incorrect. That doesn't matter. What I'm doing when I draw joint forces acting away from the joint is I'm assuming that those joint forces are in tension. If I find out that my direction's wrong, it simply means that my joint forces are acting in compression. I will do that very same thing with the method of sections. Once I cut a section using this method, I'll always draw my unknown forces, which really are my joint forces. I'll always draw them acting away. Okay? So, what's the process, the solution process all about? Well, you can write this down a couple of different ways. Some people have more steps, some people less steps. But I usually talk about a solution process using the method of sections. The first thing is solving the support reactions. Now, with this, I'll say maybe. Okay? With the method of joints, we said, number one, solve the support reactions, and you always had to do that. With the method of sections, you might find a problem here or there that doesn't require this. But you should probably go into every problem thinking, yeah, hey, I've got to solve the support reactions. The second step is to cut the truss through the member or the members that you wish to solve for. Basically what you're going to do here is you're going to create a new free body diagram. Okay? So we'll do this here in a moment. We'll do an example. But basically what's going to happen is you're going to cut a section through the truss, cutting the members that you hope to find. Now I'm going to put a little asterisk next to what I've just said here. You probably don't want to cut any more than about 3 members. Okay? Not to say that that's an absolute maximum, but here's what's going to happen. How many equations of equilibrium do you have? in a typical two-dimensional problem? You typically have three, okay? You have sum of forces in the x direction, you have sum of forces in the y direction, and you have sum of moments about a point. Actually, you could say there's more than three because you could sum moments about a variety of points, but typically we're stuck with about three, okay? So if you only have three equations, you probably don't want any more than three unknowns, okay? Now again, there's certain problems that we can, depending upon how the truss is set up, we might be able to get by with four unknowns, but for you, starting out, you should think, I don't really want to cut more than three members, okay? So when you create your new section, your new free body diagram, try to think, I don't want to cut more than three members, And again, there's an asterisk next to that. You could potentially, but a lot of times that's probably good advice. All right? With your new free body diagram of the section, okay, you're going to write equilibrium equations. And you're going to solve. So really, this is no different than what we've been doing for really the past several weeks. We've been solving for support reactions. We've been writing equilibrium equations, and then we've been solving. Here, yeah, most of the times with method of sections, we're going to solve for the support reactions. We're going to do this special step where we create a new free body diagram based on a section or cutting the truss through the members that we want to find. Okay? And with our new free body, our new section, we're going to write equilibrium equations and solve. So really, this method only has one different step in it. And that different step is the step of cutting the section and creating the new free body diagram.